Welcome back again. Here we are covering 2.3. So 2.3 is solving linear equations in one variable. So basically this section is just a recap of the first two sections. You're going to be applying all of those properties together. Okay, so that's the goal here, is to be able to look at the problem and work through it and apply all of the properties. All right, so let's get started. Let's do several examples. Let's go ahead and solve for x. And we're given 3 times the quantity of x plus 4 equals 6, okay? So what we're going to do is order of operations, right? It's a great place to start. So we're going to look at the parentheses. I can't do anything inside the parentheses, but if I look out in front, there's a 3 that I see that we can distribute. So that's going to be our first step for solving this problem. So now I'm doing 3 times x is 3x, and 3 times a positive 4 is a positive 12 equals 6. Okay, now we're going to start applying our properties. So I need to move the 12 over, right, because it doesn't have a variable, over with the 6, opposite operation. So we're going to be subtracting 12 on both sides. So I'm going to bring down that 3x, 12 minus 12 cancels, equals, now I have 6 minus 12 gives me a negative 6. Okay, now I have a 3 times x, so the opposite would be division. So we're going to divide both sides by 3. So I have x equals negative 6 divided by 3 is a negative 2. Okay? All right, so that's our first example. So hopefully that wasn't too bad for you. All right, let's do this next one. 2 times the quantity of x minus 3 plus 3 equals 9. Okay? So same deal, order of operations. Let's start there. Can't do anything in the parentheses, but we learned the distributive property, and there is a 2 to distribute. So 2 times x is 2x, 2 times negative 3 is negative 6. Now don't forget to bring down this plus 3 equals 9, right? It's part of the problem. So now we're going to combine like terms on the left-hand side of the equation because I have a negative 6 plus 3. I can make that problem simpler. So we're going to bring down that 2x. So I have a negative 3 plus 3. So that leaves me with a negative 3 equals 9. Okay, so now that we tackled that, now we're solving for x. So I need to move the 3 over so I can keep the x on the left-hand side of the equation. So we're going to do the opposite by adding 3 to both sides. So bring down that 2x. Negative 3 plus 3 cancels and becomes 0. Bring down the equal sign. 9 plus 3 is 12. Now we can perform the division property, right, because this is 2 times x. So we're going to divide both sides by 2, and x is 6. 12 divided by 2 gives you 6. Okay? So it's just applying all of the properties. Let's do one that's larger. Let's do one that's larger than that. Let's do 7 times the quantity of x minus 3. We're going to add 5 to that, equals 4 times the quantity of 3x minus 2, and then we're going to subtract 8 from that. Okay, so this one has a little bit of work, but you can do it, okay? Order of operations, can't do anything in the parentheses, but if you notice, I can distribute the 7 and I can distribute the 4, so that's where we're going to start. So 7 times x is 7x. 7 times negative 3 is negative 21. Don't forget to bring down that plus 5, okay? Now I'm going to distribute the 4. 4 times 3x is 12x, and 4 times negative 2 is negative 8. And then don't forget to bring down this minus 8 here on the end, okay? Now we're going to see if we can make the problem simpler, right? The less numbers we have to deal with, the better. So I notice here, I can combine negative 21 plus 5, right? They're like terms. So now I am doing 7x, negative 21 plus 5 is a negative 16 equals. Well, now if I look on the right-hand side, I also have like terms of negative 8 minus 8. So remember, you can add that negative, so bring down that 12x, so we end up with a negative 16. Okay, so make sure you remember those sign rules we learned way back in the beginning of the semester. Okay, now, this is just like a problem that we did earlier in another section. And when all the x's move to one side of the equal sign, and when all the numbers, all the constants move to the other side. Okay? Opposite operations. So I'm going to subtract 12x on both sides, okay? So that I end up with 7x minus 12x, I get a negative 5x minus 16 equals, well, 12 minus 12 cancels and becomes 0, and I'm bringing down a negative 16, okay? And that's right from here. You have to take the sign with it. So if it's a positive 16, it's going to be positive. If there's subtraction, remember subtraction is the same thing as a negative, bring down that negative. Okay, now I need to move this negative 16 over. Well, this is subtraction, so I know that I need to add 16 to both sides. Well, negative 16 plus 16 cancels and becomes 0. I'm going to bring down that negative 5x equals negative 16 plus 16 becomes 0. So let's finish out the problem. I know I need to divide both sides by negative 5 because this was multiplication. So now I have x equals, well, 0 divided by negative 5 is 0. So remember, 0 divided by any number is 0, okay? So our answer is 0 for this particular problem. Okay, let's see what else we can do. Let's do another large problem, okay? Make sure we're applying everything we've learned so far this semester. So let's look at 4 times 3x minus 2 minus the quantity of 6x minus 5 equals 6 minus the quantity of 3x plus 1, okay? All right, looking at this problem, right, we have a lot going on, but we're solving for x. So first thing we're going to start with, can we do the parentheses? Nope, so we're going to look out in front and see if we can distribute. Well, first I see I can distribute this 4, so let's go ahead and do that. 4 times 3x is 12x. 4 times negative 2 is negative 8. Now, if I look at this next part of the problem, I can distribute, remember, there's always that 1 that's assumed, so I can distribute a negative 1 to the 6x minus 5. So negative 1 times 6x is negative 6x. Negative 1 times negative 5 is a positive 5. All right, so I just eliminated those parentheses. Okay, so let's look on the right-hand side. Same thing. There's a negative here in front of the parentheses, which means I can distribute a negative 1 to what's inside the parentheses. So I'm going to bring down the 6. Now, negative 1 times a positive 3x is negative 3x, and a negative 1 times a positive 1 gives us a negative 1. Okay, now I still have a lot of numbers, and I want to simplify this problem. So let's look at the left-hand side and see if we have any like terms. And we do, right? I have a 12x minus 6x. Those are like terms. So 12 minus 6 gives us a positive 6x. Now I have a negative 8 plus 5. Well, that leaves me with a negative 3, okay? So I just simplified that left-hand side and I made it a whole lot easier. Looking on the right-hand side of the equal sign, I notice I have a 6 minus 1. That leaves me with 5 minus 3x, okay? So we're still doing good. We simplified the problem. Now I need all the variables on one side and all the constants on the other, and we're going to use the opposite operations. So let's move the negative 3x over by adding 3x to both sides. So 6x plus 3x gives me 9x minus 3 equals 5, and the negative 3x plus 3x cancels and goes away. Okay, becomes 0. So now I need to move the negative 3 over to the right-hand side. So we're going to add 3 to both sides. So negative 3 plus 3 cancels. I'm bringing down my 9x equals 5 plus 3 gives us 8. So now I have 9x equals 8. So we're going to use that division property. We're going to divide both sides by 9. So 9 divided by 9 becomes x. And we're left with 8/9. So you could end up with a fraction, and that's completely fine. Just make sure it's simplified, right? We always simplify fractions if possible. This one you cannot, so we're okay here, okay? All right, I have 2 more types of problems to show you in this section. There's a couple more examples in the notes if you need them, okay? So let's look at this problem. Let's look at 3 times 5x plus 1 equals 10 plus 15x. So this is one of those special types of problems, so I would pay close attention to maybe this particular problem, this type of problem I should say. And let's go ahead and start solving. Can't do anything in the parentheses, but I see I can distribute the 3. So 3 times 5x is 15x. 3 times the positive 1 is positive 3 equals 10 plus 15x. So now I want to start moving stuff around, right? I want my variables on one side, my constants on the other. So let's go ahead and subtract 3 on both sides. So the 3's cancel. I now have 15x equals 10 minus 3 is 7 plus 15x. So now I need to move the 15x to the left-hand side, so I'm going to subtract it, right, because we got to do the opposite. Well, 15x minus 15x, well, that cancels and becomes 0, equals, well, I'm left with 7, and 15x minus 15x cancels and becomes 0. Remember that sign I showed you in an earlier section? The equal sign with the slash does not equal, okay? This could happen when you solve a problem. More times than not, you'll have a definitive answer. Every once in a while, you're going to have a problem that this happens, okay? And when this happens, this is called a contradiction, okay? Contradiction. So this is a false statement. So your answer would be no solution, okay? This is a contradiction. No solution. 0 cannot be equal to 7. So when this happens, you have no solution. There's no solution to the equation. Okay, so like I said, this could happen. It's rare. More times than not, you're going to end up with a definitive answer. All right, there's one more special case besides a contradiction. And let's go ahead and do... I got 2 examples. Let's do one of them. Let's do, this one works. All right, let's do negative 4 plus 8x equals 2 times the quantity of 4x minus 2. So same deal, we're going to start solving for x. Can't do the parentheses, but I can distribute the 2. So we're going to bring down that negative 4 plus 8x equals 2 times 4x is 8x, 2 times negative 2 is negative 4. Now we're going to start moving the variables around and the constants around. So let's say, let's add the 4 to both sides. Well, negative 4 plus 4, well, that cancels and becomes 0. Plus 8x equals 8x, right? Because that negative 4 plus 4 cancels and becomes 0. So if I subtracted 8x on both sides, I end up with 0 equals 0, okay? 0 equals 0. This is called, with my terrible handwriting, an identity, okay? Because each side is going to end up with the same result, okay? So your answer is all real numbers. That's what you would write for your answer. So if you end up with 0 equals 0, or 2 equals 2, 20 equals 20, that's an identity, and your answer is all real numbers, okay? You may have 1 or 2 of those. Same thing with the contradiction, right? The no solution. Most times you're going to end up with a solution, okay? There's more examples here. There's more help under the resources, under modules. And please reach out to me if you need help as well. All right? Thanks, guys.